equal to 90 degrees. Remember, if you are given a vertical line, if you are asked to write the equation, that equation must start with x. If you remember your linear function, remember you were taught last year the linear function, and this year as well, Mr. Chiponda also taught you. Now, any vertical line has got an equation, and that equation must be in terms of x. So it will always be equal to x, will be equal to the value where the line passes through. So this line here passes through where x is 90 degrees. Therefore, the equation of this asymptote is going to be x equal to 90 degrees. You can get a question on the tan graph asking you to write the equations of the asymptotes. The second equation will be x equal to 270 degrees. So the two asymptotes have got equations. Okay? And the first equation is x equal to 90 degrees. The second equation is x equal to 270. So add that on your graph. Now going forward, all the graphs we drew for tan, make sure you also add the equations of the asymptotes. All the graphs we drew. It will always be the first asymptote always pass through where x is 90, the second one where x is 270. Always in grade 10. Please, that's only true for this grade. Next year, we are going to end up having horizontal shift, so the asymptotes will also shift. But in this grade, those are the two equations of the asymptotes. Okay, any question? All right, so let's sketch the second one. Now remember, okay, I'm not going to draw a table here. You should have your table already, but I can do it mentally. Okay, so when x is 0, remember the equation was g of x equal to 3 tan x plus 1. I hope you remember what we did last time. That's where we stopped. Right? So let's plot the key points. When x is 0 here, okay, tan 0 is a 0. So x is going to be, so y is going to be a 1. Then we have got 45 degrees. Tan 45 is 1. So 1 times 3 will give you 3. 3 plus 1 will give you 4. Please don't do this because it requires a bit of some experience. Right? Yes, it requires some experience. You must use your calculator. Don't say, Mr. Chiponda did it without a calculator, did it with and then you want to try it. No. Okay, you can end up making unnecessary mistakes. So you must use a what? A calculator. I showed you how to use a calculator. Right? Then tan 90 we are going to ask asymptote. Okay? Then, okay, this is quite interesting. Then we have got 135. Now, at 135, if I put 135 where there is x there, tan 135 gives me -1. -1 times 3 will give me -2 plus 1, I'll get -2. Then, we are going to need to know the x-intercept. Okay, but I'm going to find that later on. Then, at 225, tan 225 will give you a 1. So the same value that I got for 45, that's the same value that I must get for 225. Tan 225 is also a 1. Then at 270, we have got an asymptote. Okay, at 315, the same value I got for 135, that's the same value I must get here. Okay, tan 315 is -1. -1 times 3 gives me a -3. -3 plus 2 plus 1, I'm going to get Let me use the correct color there. I'm going to get negative 2. Then tan 360, it will always give you a 0. So 0 plus 1 will give you a 1. So my 1 is going to be here. Now the next thing now is for me to determine the two x-intercepts. Now, the first half of the curve, it goes like this. Okay, it goes like that. The second one, between 90 and 270, it's a full tan curve. But I need to know where is the x-intercept. So we'll do a calculation quickly down here. I can do it at the top. Let me do it at the top here. Okay, so if I put 0 where there is g of x, I'll get 3 tan x plus 1. What am I trying to do? Huh? I'm trying to what? I'm trying to find the x-intercept. Okay? So you substitute y for this. You solve this. Right? So it becomes 3 tan x is equal to minus 1. Therefore, tan x is going to be minus a third. Now, what is shift tan of negative a third? What is shift tan of negative a third? Huh? What is shift tan of negative a third? It's negative what?
18.
Negative 15.
18.
18 degrees. Okay. Now, negative 18, I'm sure you can see that we have got positive angles here. Okay? We have got positive angles. Now, if I want to convert that minus 18 to a positive angle, I must add 180 degrees to it. So, what is minus 18 degrees plus 180? You get what? 162. Let's go further. How many of you still remember their patterns? Raise your hand. Remember, we did trigonometry in term 2. You remember your quadrants?
Yes.
Right? Tan is negative in which two quadrants? Tan is negative in which two quadrants? Second and what? And the fourth. Second and the fourth. Now, what this tells us is that when I indicate the two x-intercepts, one of them must be in the second quadrant. So how do I get the value in the second quadrant? You say minus 18 degrees plus 180. You get 160 what? 162. Can you use your calculator? Don't just look at me. You have got your calculator. What is minus 18 plus 180? You get 162. So let's approximate where 162 is here. So this is 135. That's 180. Right? Between the two, okay, what is half of 45? What is half of 45? 22,5, isn't it? So if I add 137 to 22,5, I'm going to get somewhere in the middle here. Right? Which means I'll get 157 something, isn't it? I'm not talking to myself. Right? So 157 is somewhere there. So I can approximate 162 to be somewhere here. 162 probably be somewhere there. I'm approximating because my grid cannot allow me to exactly pinpoint where 162 is. It's not possible. So I just have to approximate. Okay? Why do we have 162 degrees? It's because the ratio of tan 162, it's a negative ratio. It will be negative what? 1/3. You know, I think next year I'm not going to allow the fact that we teach trig graphs after a while, because some of you will have forgotten the basics of trig. If the ratio is negative, okay, the tan ratio is negative, it tells you that the angle is either in the second quadrant or it's in the what? Fourth quadrant. Okay? So in this case, your calculator gave you a negative angle. Now, did I tell you about negative angles when I taught trig in term 2? Are you sure? Huh? Are you sure?
Yes,
Yes.
Okay, I'll just tell you this. All your angles are measured as positive in an anti-clockwise direction. So if it's clockwise, they will be negative. I'm going to repeat that. In trigonometry, we measure our angles as positive in an anti-clockwise direction. If it's clockwise, then the angle becomes what? Negative. So if I draw a Cartesian plane, allow me to just move on to the next. So if I draw my Cartesian plane like this, minus 118 degrees, sorry, minus 18 degrees is not in the first quadrant. It's going to be in the what? Fourth quadrant. So I'm saying, when we go in that direction, the angles are positive. This is anti-clockwise. Yes. And we measure them from the x-axis in a clockwise direction. I told you that. Don't say that I didn't tell you. I told you. Right? Then, if the angle is negative, we go in that direction. So this will be negative. And that's the positive. Okay. Just to let you know, in grade 10, we don't get into the details of negative angles. That's a grade 11 concept. Okay? But please be aware that all angles that are positive, they are measured from the x-axis in an anti-clockwise direction. All angles that are negative are measured from the x-axis in a clockwise direction. So minus 18 degrees is going to be in the fourth quadrant. And if the fourth quadrant tan is negative, which means there is an angle in the second quadrant which also gives us the same ratio. So here now, if you are in the fourth quadrant, you are going to get an angle which gives you the same ratio in the second quadrant. You just add 180 to this minus 18, and you get what? 162. Well, some of you, your body language is telling you, what did you say? Huh? No, I'm not going to mention a person's name. Listen, when you come to the math lesson, please, like in this case, you just had a brain, not very complicated. Okay? This is not very complicated. I'm saying, when you measure angles, in trigonometry, we measure angles from the x-axis in an anti-clockwise direction, if they are positive. Okay? If they are negative, we measure them from the x-axis in a clockwise direction. So minus 18 degrees is in the fourth quadrant. But the ratio of tan in the fourth quadrant is what? Negative. So if you take now your calculator and say tan minus 18, you will get a negative ratio. Do that. Do it. Tan minus 18. Right? Then, now, if you are aware that tan is negative in the fourth quadrant, it's also negative in the second quadrant. It means there is another angle in the second quadrant which gives you the same ratio as minus 18. But that angle is now positive. We can consider the positive of that angle if we measure it from the x-axis in an anti-clockwise direction. So how do you get the angle which is positive in the second quadrant? We add 180 degrees to minus 18 and you get 162. So So now punch 162 in your calculator, tan 162, and see what answer you get. You get the same answer as the one you got for tan minus 80. Okay? So that tells us that since on our grid here we don't have minus 18, then we convert minus 18 to a positive angle, which is an obtuse angle, and that angle is going to be there. Right? Now, do you remember last week I told you that once we find the first x-intercept, the distance between the two x-intercepts is always equal to 180 degrees for the tan graph. I'm going to repeat that because some of you are not paying attention. Can someone tell us what's the distance between 90 degrees and 270 in degrees? Huh? It's 180. So the x-intercept which will be here, and the one which will be somewhere between 270 and 360, the distance between them will also be what? 180. So if you add 180 to 162, what answer do you get? What is 180 plus 162? 342. So we approximate where 342 is. 315 plus 22.5 will give me 337.5. It will be somewhere in the middle. So I'm going to approximate it to the somewhere. That's where my x-intercept is. Are you following? Okay, now let's sketch. So if I want to sketch, I can start right at the bottom here, then I'll go that way, and then we'll pass through. Okay, please allow me to just carry on here because of time. Let me stop there. Okay, so that's the graph that you're supposed to get. Yeah, Mr. Fonda is showing you from scratch. There's no reason, if it comes in the test very soon in your September control test, you do something else. Okay? So you can add the properties here. All the properties for the previous graph, right? That is f of x equal to 2 tan x are exactly the same, including the equations of the asymptotes. Everything is the same. Amplitude undefined. Period 180 degrees. Your domain is from 0 to 360, but it excludes x equal to 90 and x equal to 270. Your range is going to be from minus infinity to positive infinity. So add that on your graph. Then you also add your equation of your asymptote. Let me just add them for you here. So we have got x equal to 90 degrees, and then we have got x equal to 270. Okay, generally to